Hi everyone, I am Hiromiara, working with Dr. Aaron Batista and Steve Chase, and they are interested in the underlying mechanism of the motor cortex, a region of the brain responsible for rotatory movement, and our recent work has found that the reward signal, which is a non-motor signal, causes monotonic modulation of neural activity in M1. In this research, we used 3 monkeys performing the same hand movement task with 4 different reward volume, small, medium, large, and jackpot, and saw how the neural activity in M1 change. We found a one dimension in M1 neural population which encodes reward magnitude monotonically across 3 animals, and we call it reward axis. However, it is still unknown that the reward signal is modulated by only reward volume or changed by other contexts like motivation. To answer the question, we proposed 4 different hypotheses about reward signal reward encoding in M1. First, it is just a reward that's offered, and it doesn't matter what the context is. So for context 1 and context 2, even if we changed context, the reward encoding is represented by just reward magnitude. Second, but another possibility is that it's actually represented utility. Utility is defined as reward minus the cost or the effort that you have to invest in order to get the reward. So low cost context should be a higher projection on the reward axis. Third hypothesis is expected reward. Expected reward is defined as reward magnitude times success rate. So a high success rate task makes the reward expectation bigger and a higher projection on the reward axis. Last, expected stakes. Expected stakes is expected reward plus expected penalty. Monkeys care not only about reward but penalty. So when the penalty is big, they are motivated more on the task. So if there is a possibility of failure, they take into account the expected penalty and combine it with expected reward. To determine which hypothesis is correct, we introduced different task difficulties, which vary the cost and success rate, and impose a penalty of failure. First, the task is based on delayed reach task. Then we offer different reward to the monkey, small, medium, large. One thing I want to point out is that small is 0 milliliter. Also, as a penalty, after the monkey failed, he had to wait a 500 millisecond timeout and did a penalty reach. The penalty reach was unrewarded. At last, we changed target size to change both cost and success rate. Then we saw reward encoding in the neural population. There are the theoretical plot of 4 different hypotheses: reward only, utility, expected reward, expected stakes. In the expected reward model, since the small reward is 0 milliliter, the expected reward are the same at 0 at small reward. Also, in the expected stakes model, in small reward condition, since they care about expected penalty only, her trial has bigger expected penalty and higher projection. Then, what we saw in our data was that the plot matched with the expected stakes model, which indicates the neuron in M1 are encoding not just reward but expected penalty. As a summary, we introduced different contexts, task difficulty and penalty along with reward, and saw how the reward encoding changed. Then we found that reward encoding is depending on expected stakes. This work is supported by these findings. Thank you for your listening.